Good morning, grade 12s. I'm Mr. Leo. I'm from Kagisho Comprehensive Secondary School. I'm also a deputy chief marker in our grade 12 exams this year. Today we are going to discuss a section from the main topic, which is climate and weather. Now, if you remember this chapter, climate and weather, if I may give you a summary before I start with what I'm going to discuss today, let's go back to what we did during the course of the year. This chapter, we said it consists of 4 subheadings. The first one is your primary circulation, which is now presently been in grade 12, grade 11 this year. Please, you can also consult grade 11 textbooks if you want more information on this subheading. The next subheading, remember, primary circulation is where you study your planetary circulation. Your planetary circulation, your tropical easterly winds, your polar easterly winds, your different pressure belts, the degrees. Please go back to that work. It's also very important for this year. The second subheading is your secondary circulation, where we treated cyclones, your 2 cyclones, your mid-latitude cyclones, your tropical cyclones, and also the anticyclones, the influence of Kalahari high pressure cell. Very, very, very important in the exam. The third section of this chapter is your tertiary circulation, which is going to be our discussions today. Tertiary circulation, I'll come back to it because it is our discussion today. And the last thing that you must also prepare for this chapter is climate hazards, your global warming, climate change, and drought. So this chapter consists of these subheadings. But now for today, we are going to discuss tertiary circulation. Now, tertiary circulation, we have 2 concepts there. We have valley climate and city climate. What I'm going to do, I'm going to divide this into 2 sections. We are going to start firstly with valley climate, and then after break, we'll continue with city climate. These are the 2 subheadings that we are going to discuss under tertiary circulation. Now let's look at the concepts that we must know under this subheading. Tertiary circulation is a study of climate on a very, very small scale. On a very small scale. That is why we are now going to look at what is happening in our valley, especially during winter. What is happening in our city. Here the focus will be more on one of the land use zones known as CBD, your Central Business District. What is happening there during winter at night. We are also expected to know some of the concepts, like you see there, the microclimate, the study of climate on a small scale. That is why we even call it the local climate, or on a local scale, on a very, very small scale. We move to the next concept that we must also know is the aspect of the slope. Now, what is this? The aspect of the slope, I'll show you after I've completed this presentation under this subheading by means of a sketch. What do we mean by these concepts? The aspect simply means the direction in which a slope faces. The slope can face to north or to south or to east or west. Those are our directions. So we are going to also to elaborate on this concept, the aspect. The next concept that we must also know is the angle of incidence. The angle of the incidence. This is the angle at which the sun rays strike the surface of the earth. Sun rays striking the surface of the earth at 90 degrees, which can say those what we measure perpendicular, or are they striking the land surface at oblique angle? Because those they will have an impact, but we'll discuss that later. Then we have a term, a shadow zone. Yes, in a valley, there will be a shadow zone. A shadow zone will be that area of the land which does not receive strong sun rays. Obviously, this part of your slope will be more cooler or cold than the other side because it gets less sun rays. It does not get strong sun rays. Then we have, going back to the aspect, then we can say we have what we call north-facing slopes. Then here I said north-facing slopes versus south-facing slopes in the southern hemisphere. That's where we are. Now, the north-facing slope will be those slopes that are facing to the north, to the direction of north. Then the south-facing slopes will be those slopes facing to the south. And then, by means of a sketch, I will try to explain some of these concepts to you. Let's look at the following sketch so that these concepts, they can be more easier for you in the exam. We spoke about the aspect. We spoke about the aspect, this part. This part is your aspect. Then we spoke about the concept, the angle of incidence, the angle at which the sun rays strike the slope. And then we also spoke about the shadow zone. Now let me use this sketch that I have here to explain this concept. Now here, let's assume that, or let's say this is a valley in the southern hemisphere. That's very important. In the exam, check your directions. Check your directions because they will help you to know where the valley is. Now, the sketch that I have, we have a valley in the southern hemisphere. Now, slope A will be what we call north-facing slope. This slope is facing where north is. And then slope B will be our south-facing slope. Now, in the southern hemisphere, the north-facing slopes gets more perpendicular or more strong sun rays than the south-facing slope, which simply means in the southern hemisphere, the north-facing slope, that's this slope where the A is, will be warmer than the south-facing slope. That is why if we go down here, slope A will be warmer than slope B. Then on the side of slope B is where now we get less sun rays, which will be our shadow zone. So, but now you must be very careful that when you cross the equator and you go to the northern hemisphere, it's going to be the opposite. In the northern hemisphere, let me start with southern hemisphere so that you can understand me. In the southern hemisphere, we say the north-facing slopes are warmer than the south-facing slope. But when you get into the northern hemisphere, it's going to be different. Your south-facing slopes, in the northern hemisphere are warmer than the north-facing slopes. To simplify this, all the slopes that are facing toward the equator, when you draw a globe, they will be warm. So remember that in the north, your south-facing slopes are warm. In the southern hemisphere, the north-facing slopes are the ones that are warm. And we also have to be careful in the exam, you may find the examiner giving you a valley. For you to know in which hemisphere is this valley, if they don't give you a place, like maybe this is a valley in Lesotho or a valley in Free State, check where your directions are, your north and your south. You must also check where you have settlement. Settlement, check where there is agriculture. Agriculture and settlement, they are normally on the same side. Then the other side, you may find that you have your pine trees, you have grazing or pastures. So once your buildings or agriculture is on the slope A, it means that is the slope that is warm, where you have settlements, where you have agriculture going on. That will be the slope that is warm. So with these two directions, then you will be in a position to tell in which hemisphere is this valley. I hope I'm clear. You check the directions, you check human activities like agriculture, settlement, because they will normally be on the warmer slope. Now, before I go to the next point, I have here in the southern hemisphere, just to summarize, slope A, which is your north-facing slope, is a warm slope. Then slope B, which is your south-facing slope. Slope B, which is your south-facing slope in the southern hemisphere, is cold. Then I said in the northern hemisphere is going to be the opposite. Please don't forget that. It's going to be the opposite. Right. Then we can now move to the next point, where now we are going to discuss what is happening in the valley. The valley, I said, you check your slopes. We have what we said is a valley slope, or what we say is a north-facing slope and south-facing slope. Now coming to what is happening in the valley, we have cold winds during winter, which are going to blow down the slopes of the valley. They are going to blow down because they are cold during winter at night. They are blowing over the land, which has lost heat starting from in the afternoon. So at night the land will be very cold. So this will influence now these winds to be cold. Now because they are cold and they are heavy, they are going to move down the valley, but being close to the valley slopes. That's what is very important. Being very close to the valley slope, and those winds that are blowing down the valley slopes during the night in winter, they are called katabatic winds, or we can simply call them downslope winds. Now these katabatic winds, I said, we have them during winter, at night, and they are very cold. These winds blow down the valley sides, which are your valley slopes. They move down the valley slope, and then I said they are called katabatic winds. When they get to the valley floor, these winds are going to decrease the temperatures at the valley floor. So the temperatures at the valley floor will decrease once these katabatic winds gets to the valley floor. Now, by means of diagrams, I'm going to try to show you these winds, what we call the katabatic winds, and what we call, let me start with the katabatic winds before I can go to the other winds. My first sketch this sketch here, I have a valley. This will be valley slopes. Then down here will be our valley floor. We have cold winds moving down slope. Arrows are facing downwards. We have a half moon, which is an indication that this is happening during the night. So these are our katabatic winds. What is important, because I'm going to move to the next sketch. What is important is that these winds are cold. They move down slopes to the valley floor. They are just next to the valley slopes, moving to the valley floor. The next winds that I want to show you are these ones on this side. These are our anabatic winds. Anabatic winds, or what we call upslope. This one I said they are our downslope or katabatic winds because they are moving downwards. These ones we call them anabatic or upslope. They move upwards. That is why I also have a sketch that trying to show you that with these winds there is that possibility of condensation to take place and we may have clouds. Here there is no possibility of clouds because winds are moving downwards. Winds are subsiding. These anabatic winds are taking place during the day, this one during the night, this one during the day. Then let me go to the next sketch. These two sketches, I know in some textbooks we only have katabatic winds and anabatic winds. But I want to make you aware that in some textbooks we have these winds and also these winds. I said these winds are called katabatic. They are moving next to the valley slope. Now let's look at these ones. These ones are also moving downwards. They are getting to a valley floor, but they are not blowing next to the valley slopes, which means these are also cold winds during winter at night, but these cold winds are blowing from the mountains and they go straight to the valley floor without blowing next to the valley slopes. So the main difference between these two winds is that these ones are blowing next to the valley slope, these ones are blowing from the mountains going straight to the valley floor. Now these ones that are moving from mountains going straight to the valley floor are called mountain winds. I said this, we call them katabatic winds. These are called mountain winds. Right. The next set of winds, I said we have anabatic up, which are also known as upslope winds, blowing next to the valley slope, going upwards, condensation during the day. Now we have these winds that are now moving from the valley floor, without moving next to the valley slopes, going upwards because they are warm, they can go or rise on their own, they are light, then they go up, and there are also possibility of clouds because condensation can take place here. Now these winds, they differ from these ones because they are not moving next to the valley slopes. And now these are what we call valley winds. We have mountain winds, we have valley winds, we have katabatic winds, we have anabatic winds. I hope in my next explanation that will be more clear. Please don't forget the sketches that I have just shown to you. Let's look what I have on this notes. I said in the valley we have katabatic winds, we have anabatic winds, we have katabatic winds, which are taking place during winter at night, and they are cold winds. These are winds blowing down the valley sides, valley slopes, your katabatic winds. They are called katabatic winds. They will decrease the temperature at the valley floor because they are cold. Then during the day, I said we have winds moving up slopes from the valley floor, going next to the valley slopes. Remember, those are your anabatic winds, going up, anabatic winds or upslope winds. We have them during the day when the valley floor gets sun rays. Warm winds from the valley floor will blow up the sides, from the sides of the valley, and they are called anabatic or upslope winds. Then we have mountain winds, which I said these are winds blowing from the mountains, going straight to the valley floor. Then we have also valley winds, which I said these are warm winds moving from the valley floor, going upwards, with the possibility of condensation and cloud formation. Right. Now let's go back now to our valley. Now, in a valley, from what we have just discussed, we can have katabatic winds, anabatic winds, mountain winds, valley winds. Please check the arrows and also check whether are these winds blowing downwards, being next to the valley slope, or are they blowing downwards, going straight to the valley floor. That's where you can be able to make the difference. Now, in a valley, we have what we call valley inversion. Now, for us to understand valley inversion, we first have to start with the concept of what is temperature inversion. Temperature inversion is an increase in temperature with an increase in altitude. Altitude simply means height, which means if temperatures are going to increase as you move upwards instead of decreasing, that is what we call temperature inversion. Now, in a valley, during winter, we have this valley inversion. Now, I'm going to explain how valley inversion takes place. Temperature inversion in a valley, which will now take us back to what we have discussed, the katabatic winds, which are cold and dense. They will sink. They will move downwards at night, going to the valley floor, going to the valley floor. And then when they get to the valley floor, these katabatic winds, they are going to displace warm air which was right at the valley floor. Now this cold air which is going to settle at the valley floor is going to displace warm air which was here before. We should first remember that these arrows, this will be our katabatic winds. At night, moving downwards. Then when they get to the valley floor, they push or they displace warm air upwards. Then the valley floor will be full of cold winds. These cold winds will settle here and decrease the temperatures here at the valley floor, which means it will be cold here. Now the warm air which has been displaced from the valley floor will be here. Will be here. So which means this area will be having warm air. Now this warm air will be on top of cold air. Then we also have cold air there. This is the air moving over the land surface. But going back to this area, which consists now of warm air, which was displaced from the valley floor. This area will now be warm, because it has warm air. This area down here will be cold, because it will have your katabatic winds, those cold winds that moved down the valley during the night. So if we move from this point, from the valley floor, and we go upwards, it means there will be a change in temperatures. We will be moving from a very cold area, which will be your valley floor, very low temperatures. But when we get into this area, then the temperatures will increase because it consists of warm air. So now I think now you can see that there is something that is unusual here. That you are moving from a very cold area, you are getting into a warm area. So the temperature has increased with an increase in altitude, with an increase in height. So this is what we call valley inversion. So valley inversion to take place, good learners, is that we must first have katabatic winds going into the valley floor, going to displace or going to push warm air upwards because it is light. Now this warm air will settle on top of cold air. So when we move upwards, we will be moving from a very cold area consisting of katabatic winds, getting into a warm area. So now that is your temperature inversion. Now this part that consists of warm air is also known as thermal belt. It's also known as thermal belt, and it will be the warmest area in the valley during winter because it will be having warm air. Before I go to the next concept, let me just quickly go over what I said about valley inversion so that we can understand. Valley inversion takes place in a valley at night during winter. You have your katabatic winds moving downwards next to the valley slopes. These cold winds, which are called katabatic winds, are going to settle here at the valley floor, pushing warm air upwards or displacing warm air upwards. The warm air will settle on top of cold air. So when we move upwards, we'll be moving from a very cold area, getting into a warm area. So that is your temperature inversion. Because I said temperature inversion is an increase in temperature with an increase in altitude. Right. I think now we can move to the next point. In a valley, the accumulation of cold air at the bottom of the valley in winter, these katabatic winds, because I said they are very cold, they are going to decrease the temperatures at the valley floor. And there's that possibility of water or vapor changing into ice crystals or forming ice crystals at the valley floor. So once we have ice crystals at the valley floor, then we'll say that is what we call frost pocket. So frost pocket is nothing else but the formation of ice crystals at the valley floor because of katabatic winds, which are very cold at night during winter. So water, if maybe we have a river at the valley floor or we have a vapor changing into ice crystals, then that will form what we call a frost pocket. Now, this frost pocket has influence on farming in a valley. It will also have influence on where we can have our settlements. Because if we have frost pocket at the valley floor, some of our crops will not grow there. They will die. But there will be those that prefer those cold conditions. We as human beings, we also prefer to have our settlements on a warm slope. So we will always try to avoid to have settlements at the valley floor because of cold conditions, because of the possibility of a frost pocket. So the best area in the valley to have our settlement will be where we will have warm air, your thermal belt, because during winter that area will be warm and it will be more suitable for settlement. That is our valley inversion and what we call development of frost pocket. I said there will be accumulation of cold air at the bottom of the valley in winter. Now this accumulation of cold air at the bottom of the valley, good people, let's remember this will be our katabatic winds. And I said these katabatic winds are going to decrease the temperatures at the valley floor. Then there will be formation of frost or ice crystals, and this will now take us to what we say we have a frost pocket. And this frost pocket will affect farming in a valley, because I said there will be those crops that cannot grow under those cold conditions, but there will be those that can grow there. And this will also influence where we would like to have our settlements. I said as human beings, we normally prefer to have our settlements on a warm slopes. That will be your thermal belt, that area in the valley that consists of warm air. The other thing that can also happen in a valley is the formation of radiation fog. Now, radiation fog is formed when warm air come in contact with cold surface. We are talking about terrestrial radiation. We are talking about terrestrial radiation. You will find that in the morning, the temperature inversion on winter morning can be seen as a layer of cloud over a valley. This low level of cloud formed as a result of loss of heat or radiation at night. This will be our low level clouds, which will be called radiation fog. I will explain that later. A fog forms when dew point temperature is above 0 degrees. It's a fog, which means when temperatures are above 0 degrees. In a valley, there will be something like clouds in the morning. And this will be clouds that are very close to the Earth's surface. But because they are very, very close to the Earth's surface, then we'll call it what we call a fog. I said a fog will be formed when warm air come in contact with cold land surface, which means your condensation is now taking place very close to the Earth's surface. Then we'll have a fog. But what is important is that the temperature must be above 0 degrees. It must not be below freezing point. Because once the temperature is below freezing point, then we have a frost pocket, the possibility of frost pocket. And a fog is more or less similar to clouds. The only difference is that a fog is formed very close to the Earth's surface. We sometimes call it a mist, but that depends on its thickness. So it's a cloud formed very close to the Earth's surface because of the contact of warm air with the cold land. And that type of a fog is called radiation fog, because the land lost heat through terrestrial radiation. So that fog is called radiation fog. Now to summarize this, I will go back to what I started with. I started with the naming of slopes in a valley. I also tried to explain certain concepts. I started with the naming of slopes, your north-facing slope, your south-facing slopes, which slope is warm in the southern hemisphere, which slope is warm in the northern hemisphere, and why is this slope warm. I said in the southern hemisphere, the north-facing slopes are the ones that are warm because they get perpendicular sun rays. And then the south-facing slopes are cold in the southern hemisphere. But in the northern hemisphere, it will be the opposite. Then I also spoke about frost pocket. A frost pocket, I said, is when water or vapor changes to ice crystals at the valley floor because of katabatic winds, which are now at the valley floor, making temperatures to be very, very low. And I said this frost pocket will influence settlements, will also influence farming, We also have a thermal belt. Remember, what is a thermal belt? A thermal belt is that area in the valley which will consist of warm air. Now, this warm air was raised by katabatic winds, pushed upwards, and ended up settling on top of your cold winds. So it means you have warm air right in the middle of your slope, mid-slopes. Then that is your thermal belt. And I said this is the best area where we can have our settlement because it will be warm during winter at that area. And once you know thermal belt, then you should also be in a position to explain how valley inversion takes place. Because to have a thermal belt, it means we must first start with temperature valley inversions. Your cold winds, katabatic winds, moving down slope, settling at the valley floor, pushing warm air upwards, so that when we move up, then the temperatures are going to increase, and that we call it temperature inversion. I also spoke about your fog, which will be formed when warm air come in contact with cold land surface. Condensation taking place very, very close to the Earth's surface. And then it will form what you call a fog. But now in a valley, we can also have pollution, more especially if we have industries operating at the valley floor. And this pollution will affect our health. It will also affect production because it's going to affect the employees' health. We can also have what we call a smoke from factories. Now, a smoke is when you have a mixture of a fog. A fog, remember what I said, is a fog. It's something like similar to clouds, but being formed right close to the Earth's surface. You have your fog, a mixture of a fog and smoke. So then it will form what you call a smoke, which is also not good for our own health. So that is why we normally say it is not advisable to have any industrial activities taking place in a valley. But once we have industries in a valley, I mean it will be a waste if we go and destroy those industries. We need to come up with sustainable measures to try to reduce pollution in our valleys, because those industries are there. Then we need to come up with very, very good strategies or measures to reduce pollution in our valleys. If I may mention only two, what we can do to make sure that we don't have more pollution in our valleys, we can make the chimneys of our industries, which are already there in the valley. We can make the chimneys to be very, very long, to pass even your thermal belt, so that the smoke can be released in higher layers of the atmosphere and be blown by strong winds. Have a very long chimneys that will take smoke out of the valley into higher layers of the atmosphere, and then this smoke will be blown by wind. Then we can also have filters. We can also have filters in our chimneys to trap the pollutants from going out, which means we can, after a certain period of time, replace those filters. Those are some of the things that we can do if we have industries already existing in our valleys, because it will be waste to destroy them. Now, there is also another problem of possibility of having acid rain. In your lower grades, I'm sure you came across the term acid rain. Acid rain is when sulfur dioxide and nitrogen oxide mix with water or rain. Acid rain, I said, is when your sulfur dioxide and nitrogen oxide mix with rainwater. Now this acid rain, we know that is not good. It will destroy or kill some of our plant cover or crops. So we need to come up with measures to make sure that we reduce the possibility of having acid rain. This is more or less what the valley climate contains. Please know your katabatic winds, your anabatic winds, your mountain winds, your valley winds. Know the concept of temperature inversion. What do we mean by that? Explain how valley inversion takes place. What is your thermal belt? How is radiation fog formed? What is a frost pocket? Which slope is warm in the southern hemisphere? And how are you going to be able to see this slope? I said, please look at your directions, where your north is, and then where your south is. And then on the valley slopes, you must check human activities going on there. If you are able to see agriculture going on and we have settlements, it means that is the slope that is warm. Now what you have to do is just for you to check in which direction is this slope facing. Is this slope facing where north is, or is this slope facing where south is? Then you will be able to answer questions around that. Our next topic is going to be urban climate. I said tertiary circulation is divided into two: valley climate and urban climate. We have discussed the valley climate. We have seen what is happening in our valley. Now we are moving to the next subheading of this chapter, which is the city climate. The city climate, we normally start comparing the city and the rural areas. Urban climate. Now, in our discussions, please, even though we are going to start comparing our urban areas and the countryside means rural areas. The main focus here is on the CBD, which is one of our land use zones, the Central Business District. We will start discussing comparing urban settlements and rural settlements. Then we have to come and now focus on our CBD. Let's look at quickly the difference between rural and urban settlement. But before that, these are some of the things that we are going to come across. Isotherms, lines on the map, joining all places with the same temperature, thermometer, temperature. You have isobars, pressure. You have your iso highs, rainfall. Please don't confuse those concepts. Then we are also going to discuss pollution dome and urban heat island. I want us quickly to look at the comparison between the urban area and the rural areas. Urban areas and rural areas quickly. Now, urban areas, I said, our big cities, and the rural areas that we normally or sometimes call them a countryside. The temperature in urban areas, temperature is high, but less in the rural areas, because in the urban areas we have more reflective surfaces, we have artificial surfaces that reflect more heat. Clouds more in the urban areas, less in the rural areas. Precipitation or rain is more in urban areas because it's easy for condensation to take place because of more hygroscopic nuclei. Then we have humidity, less in urban areas. Less in urban areas because after rain, less water is absorbed by the soil because of tarred roads and pavements. Then you have your dust. Your dust and pollutants, they are more in urban areas because we have more cars, we have industries, we have more residential areas, and then less in the rural areas. Then radiation is less in urban areas because we have very tall buildings. In the rural areas, it's open. It's open space, we have more radiation. Now, this is the comparison between urban areas and rural areas. Like I have said, when we come back, our focus now will be on the CBD. The CBD, which is the Central Business District, where now we are going to discuss what is happening in the CBDs. Thank you very much. Until we meet again after this break. Good day again, good learners. Let's continue into our second session. I hope you were able to discuss some of the things that we discussed during our first session. Now, our second session is the last point under tertiary circulation. When I started here, I said this tertiary circulation, you can divide it into two, your valley climate and your urban climate. Now, before break, I introduced urban climate. I will quickly go back to what we discussed just before break. Under urban climate, I said we normally like to pay more emphasis on urban. But urban, you'll see as we continue, we are now going to change and focus more on the CBD, small scale. Remember, this is your tertiary circulation. Small scale, the CBD, Central Business District. Now, I said these are some of the concepts that we should know. We are going to use the term isotherms. I said these are lines on the map joining all places with the same temperature. And I also assisted you by mentioning some of the lines like isobars for temperature. No. Isobars for pressure. Your isobars are lines on the map joining all the places with the same pressure. Isotherms, temperature, isoheights, rainfall. Then we are also going to discuss the pollution dome and urban heat island. I also showed you this table where we are comparing urban areas and rural areas, the temperature quickly. We said the temperatures in our cities are higher than in the rural areas because of many reasons. We have more clouds over the cities than in the rural areas. It's easy for condensation to take place over cities because of more hygroscopic nuclei. Precipitation, more rain over the cities than in the rural areas. Humidity is less because of tarred roads, pavements, or because of less infiltration of water after rain. But in the rural areas, we have more open space, we have soil, so we have more humidity. Then dust and pollutants, more in the city because of factories, cars, you name them. And then less in the rural areas. Then radiation, I said less in the urban areas because of these tall buildings that we have. But in the rural areas, we have more radiation. Right. Now, our topic now is going to be on urban heat island. Urban heat island. We are going to discuss these 7 points. Now, what is urban heat island? If I may simplify this for you, I will say urban heat island is an area like the CBD, in a city, like the CBD, which is warmer than the surrounding areas. That is why when I started, I said we are going to change the focus to the CBD, not to the whole of Bloemfontein or the whole of Johannesburg. But we are now going to focus on the CBD of these big urban areas. So urban heat island is that area which is your CBD, which is warmer than the surrounding areas during the night in winter. We'll come back to that. Then, what really causes urban heat island? What causes urban heat island? What makes the CBD of our big cities to be more warmer than the surrounding areas? I normally like to group this into only two: your artificial surfaces and pollution. So with artificial surfaces, I mean things like tarred roads in our CBDs, tarred roads. I mean tall buildings with glasses. I mean steel. I mean pavements, right? They are artificial. They are artificial surfaces which are reflecting more heat, making the CBD to be more warm. Artificial surfaces. Then the next thing that causes urban heat island: pollution. Pollution from your light industries, pollution from heavy industries, pollution from cars, right? Those are the main causes of the urban heat island, which means these are the main causes making the CBD to be warmer than the residential area. If maybe I can just go to your settlement geography, because we have those different land use zones. So the CBD, being the center, is warmer than your residential area because of these two things. Now, how do we see urban heat island? How do we see how is normally shown? There are two ways of showing this. I'm quickly going to show you by means of two simplified sketches. The first sketch is this one, where we have our CBD in the center, your central business district. Now these lines will be your isotherms, will be your isotherms. I said these are lines joining all the places with the same temperature. They will be our isotherms. So now, if you check my numbering, you can see here I've got 5 degrees Celsius, I have 10 degrees Celsius, I have 17 degrees Celsius. So it means as you move toward the center of the city, as we move toward the CBD, temperatures are increasing. So the CBD with 17 degrees Celsius is warmer than this place here. So this is one way of showing the urban heat island. We call this the plane view of urban heat island. We can show the urban heat island by means of isobars, but check the numbering of your isobars, your degrees. They have to increase as you move towards the center, because this is the area that we say is our urban heat island, being warmer than the surrounding areas. The other way of showing urban heat island can be by means of a graph, which is normally common in our exams, by means of a graph. So they might not be so clear for you there, but here we'll have our CBD, obviously, because of tall buildings, your urban profile, you can see that we have tall buildings here, and then as you move from the CBD, then the buildings get shorter, okay? But our discussion is around these tall buildings where our CBD is. Then this side you have the numbering of your graph, 5 degrees Celsius, 10, 17, 22. Then you have this line, which is also an isotherm. joining all places with the same temperature. But what is interesting, you see this isotherm just above these tall buildings, just above this zone called the CBD. Your isotherm is going higher, which means it is higher than here. It is also higher than here, higher than there. So it means here the temperature here is higher than the temperatures of the surrounding areas. So this is your urban heat island. That is why when I started, I said urban heat island, if we may simplify it, is the area like the CBD, which will have higher temperatures than the surrounding areas. Now in the exam, the examiners, they normally like to ask candidates to give the temperature above the CBD. The temperature above the CBD. Obviously from my example here, the temperature above the CBD, you just come to this line, and then your 22 degrees Celsius here, this line goes up to there, and it just passes below your isotherm. This 22 degrees Celsius is below this isotherm. So you cannot, in the exam, you cannot really say the temperature of the CBD is 22 degrees Celsius. No. It must be a number bigger than 22. It must be more than 22. Maybe in the exam you may get a very simplified graph which can have now more numbers as you go up here. Then to get the temperature, what I want you to master is how do you get the temperature of the CBD. You use your isotherm, then you come also to your temperatures on this side. Then you check your isotherm there. Then these are the two ways in which we can show the urban heat island by means of a plane view like this, these lines being your isotherms, or by means of a graph like this. But what is important from this graph, you are now able to see that here the temperatures are high. But as you move out from the CBD, going outwards, temperatures are decreasing, your graph. That is why we say urban heat island is a place like the CBD which has higher temperatures than the surrounding areas. I hope I have explained this concept, urban heat island. We'll now move to our next point from that list of 7 points. Your number 3 is how to see an urban heat island on a map. I said we use isotherms. We can see it by means of a plane view or a graph. Now, your point number 4, our point number 4 is the effects of urban heat island on us as human beings. Now remember, urban heat island will now be our CBD, being warmer than the surrounding areas. Now, being warmer than the surrounding areas, it will affect us as human beings, the effects of urban heat islands. It can cause unpredictable rain in the CBD, which means it can cause the CBD to have more rain than the surrounding areas. It will also influence people to use more air conditioners because it will be warm in the CBD. So from our offices to start to work during the when we have this urban heat island, then we will be forced to use more air conditioners. With these high temperatures, this can also lead to more stress to our people. High temperatures, leading to more stress. Or these high temperatures in the CBD, your urban heat island, can also cause heart problems, more especially to our elderly people. So these are some of the effects of urban heat island. So now, after now we have seen the effects of urban heat island, how it's going to affect us. Unpredictable rain, more use of air conditioners, it will cause more stress because of high temperatures. It can also lead to more heart problems because of high temperatures. Then we must now come up with strategies, sustainable strategies or sustainable measures to reduce high temperatures in the CBD. To reduce high temperatures in the CBD. Now, I normally like to say to my candidates, we must always come up with solutions that are practical, solutions that we can achieve. We should not give solutions that we cannot achieve or solutions that will be against the constitution of the country. So as geographers, we need to come up with strategies, and they must be sustainable. Now, because of the effects of urban heat island on us, we now have to come up with strategies to reduce the formation of heat island. Some of the strategies that we can do, now we have a long list, a very, very long list of strategies that we can implement. But for exam, take those that you can remember them very quickly. Write down those that is easy for you to recall them in the exam. Let's start with the simplest one that we can do. We can promote the use of public transport. Promoting the use of public transport into our CBD, that will reduce the amount of pollution, which is one of the main causes of urban heat island. Let's promote the use of public transport. To me, that's the first one that I can really easily recall. We can also make our CBD to have more plant cover. Greening the city, that's planting more trees or having parks in our CBD or around the CBD. Now, with more plant cover, it means we will be able to reduce carbon dioxide. Plants will inhale carbon dioxide and try to reduce the level of pollution in our CBD. Promotion or promote the use of public transport. Let's make our CBDs to have more parks, greening of the CBD. Or we can even change some of our surfaces in the CBD. Instead of painting your building with a very, very dark color, we can paint that building with bright colors, which is something that we can achieve. Or we can also encourage what we call industrial decentralization. By industrial decentralization, we mean taking some of our industries to other areas, so that we should not have more and more industries being concentrated in one place. So you decentralize them. With that, you will be also reducing the amount of pollution. So these are some of the strategies that we can implement. More plant cover, use of public transport, changing the artificial surfaces or buildings by painting them with bright colors, or decentralizing some of our industries. More plant cover in our CBD. Then we can now move to point number 6, which is the concept of pollution dome. Now, pollution dome is a layer of pollutants covering the CBD during the night at winter. Now, this layer of pollutants will cover the CBD, not the whole of our urban area. It will cover the CBD from both sides, making difficult for warm air to escape, or making it difficult for polluted air to escape or to go out of the CBD. So this polluted air will be kept in the CBD during the night by this layer of pollutants. And remember now, it is during winter where we have this anticyclone called Kalahari high pressure cell being very dominant during winter in South Africa, causing more subsiding air, air moving downwards, making sure that this layer of polluted air covers the CBD, keeping polluted air in the CBD. Which means during the night, with pollution dome in winter, the CBD will be warm, because warm air will be kept in the CBD by this layer of pollutants. Now the problem is, how is this going to affect us? That's our point number 7. I'll come to that later. The effect of pollution dome. Remember, in this pollution dome, we have polluted air, which is not able to escape because the CBD is now covered with this invasion layer. I will use a sketch just to show you this concept of pollution dome. Let's start with this first sketch. On this first sketch, we have this line, which is our invasion layer, or a layer formed by pollutants, preventing warm air which is inside here from escaping. And this is taking place during the night. We have these arrows. These arrows will be our subsiding winds, warm, dry, subsiding winds coming from the Kalahari high pressure cell. So making now this layer to cover the CBD from this side up to this side. You can see on this sketch, the CBD, there is no way the warm air can go out from this side or from this side. The CBD is covered both sides by this layer. So this is what we call a pollution dome. A pollution dome. Both sides are closed. And then in the early hours of the following day, we will have strong winds coming from the rural areas, blowing into our city. Now when these strong winds, early hours of the following day, when they get to the CBD, they will get into this pollution dome. They will get into this pollution dome here. Early hours, around about 3 o'clock, 4 o'clock in the morning. And then once these cold winds get into the CBD here, these cold winds They're going to get into this dome and then push it upwards until it opens both sides. Once it opens both sides, then it's called pollution plume. If it is open on both sides, it's called pollution plume. It's pushed upwards. Then in the morning, around about 6 o'clock or 7 o'clock or 5 o'clock, that warm air which was trapped in here, that warm polluted air which was trapped in here, will now be able to escape early hours because your cold winds were able to get into this pollution dome and then pushes this layer upwards. That is why here now we have a day, here we have during the night, because this will be the early hours getting to the morning. So your layer will be pushed upwards and then that warm polluted air will be able to escape. Now, during the day in the CBD, we have more of this. During the day. Now here I'm not talking about early hours. I'm talking about during the day. We have high temperatures. It is warm during the day. We have warm air going upwards. So it is not easy. It is not easy for pollution dome to be formed during the day because of warm air going upwards because of high temperatures. Then during the night, it is easy for pollution dome to be formed because we have these subsiding winds. We have these winds coming from Kalahari high pressure cell moving downwards. So it is easy. It will be more easy for a pollution dome to be formed during the night because of these subsiding winds, which are going to keep this layer being close to the Earth's surface, making this area during the night to be warm, because it will be consisting of warm polluted air. So then once it opens this side, good learners, I said now, once it opens both sides, we don't call it a pollution dome, but it is called a pollution plume, and then this one is called pollution dome. Then going back to the last point about pollution dome, we are now going to look at the effects of pollution dome. Now, this concept of pollution dome, obviously it will be formed during winter, not during summer. Now, one can ask a question, why during winter and not during summer? It is because of the difference in temperatures. During summer, we have high temperatures, we have more warm air going upwards. During summer, the land surface is also warm during the night. So we cannot expect pollution dome to be formed during summer because of high temperatures. I mean, a very practical example is that during summer, we can sleep on our grasses during the night, or we can sleep on our stoops during summer because it is warm even during the night. But during winter, the land is very cold because of terrestrial radiation. So pollution dome will only be formed during winter because of low temperatures and because of the Kalahari high pressure cell causing those subsiding winds to keep our layer being close to the Earth's surface. Now we have pollution dome and pollution plume. What is the difference there? The difference is pollution dome is closed both sides. Then pollution plume cold winds were able to get in and push this layer upwards early hours of the following day. So it has been pushed, the layer has been pushed upwards. That's your pollution plume. Now, this pollution dome, now I'm talking about a dome, the one that is closed on both sides. Remember what I said? I said inside this pollution dome, we have warm, polluted air. Warm, polluted air. Then it means this pollution dome, which will be formed over the CBD, one of the problems is that it will cause respiratory diseases. Definitely it will affect us because we will be inhaling polluted air. So that is going to affect our lungs and have different respiratory diseases because of polluted air. Number two, this pollution dome will also affect or reduce visibility in the city. Visibility in the city, what we mean, it means once we have this pollution dome, then it means the CBD, it will be more dark, and that will reduce visibility in the city. It will affect our health and reduce visibility in the city. Right. Now, I think I've covered all these 7 points. Let me quickly go through them before I go to the last point for today. We spoke about urban heat island. Urban heat island, please, it's very common, very, very, very common in our exams. Explain the concept urban heat island. Get the temperatures. I said to get the temperatures, you must look for your isotherms. You must look for your isotherm because it is temperature, and then the numbering of temperatures on your graph. Then what causes urban heat island? I said I normally like to group them into two, into artificial surfaces like tarred roads, tall buildings with glasses, pavements, steel, in our CBDs, right? And then artificial surfaces and pollution. How do we see an urban heat island on a map? By means of isotherms, the planned view, and a graph. And then the effects of urban heat island on us, I said it will cause more unpredictable rain in our CBDs. It will increase the level of stress. It will also make us to use more air conditioners in our offices. And I also said it can also, this urban heat island, it can also affect our hearts, more especially elder people, because of high temperatures. Then the strategies to reduce this urban heat island, I said let's go for those that are simple to remember. Let's encourage or promote the use of public transport. Let's green our CBD by having more gardens or having more parks in our CBD. Let's decentralize some of the industries to other areas. We can also paint our roofs with those bright colors, not with dark colors, because dark colors will absorb more heat. Those are some of the strategies that we can implement. Then the concept of pollution dome. Please differentiate between pollution dome and pollution plume. The easiest way to differentiate is to check, is it open on the sides? If it is open on the sides, then it is your pollution plume, where the inversion layer or the layer formed by pollutants has been pushed upwards. Then if it is closed on both sides, then it's your pollution dome, which is common during winter because of reasons that I've mentioned, and also because of the Kalahari high pressure cell, our anti-cyclone. Then the effects of pollution dome, I said it will affect or cause more respiratory diseases. It will affect our health because we will be inhaling polluted air in this pollution dome, and it will also affect the visibility in the CBD. I hope I've covered most of the things that I wanted to share with you. Remember, this chapter, when I started, I said it has 4 sections. And this is one of the sections where we believe that you can collect more marks, because you can divide it into your valley climate and your city climate, and then try to use information that we shared today. Before I can say goodbye to you, I want to share this with you. You will be writing geography on the 22nd. On the 22nd of November, paper 1 in the morning, paper 2 in the afternoon at 14 hours. Please be on time in the morning, because you will have to read the question paper, read instructions. Come early so that you use that 10 minutes or 15 minutes that is given to you as candidates to go through the question paper and be able to decide which questions are you going to answer. Don't be late and come running, because once you come running and you find other candidates being seated and starting with the paper, you start to panic. The paper will have 4 questions. I'm not the examiner, but our paper normally has 4 questions. Out of these 4 questions, you are expected to answer 3. The advice that I want to give you is start with the one that is very, very simple for you. There is no rule that says you must always start with question 1. You can start with question 3, then after completing question 3, then you go to your next question, which can be your question 4, and then after completing that one, you go to the 3rd question, which may be your question 1. There is no rule that says you must always start the exam with question 1. Choose 3 from 4 questions and start each question on a new page. These are the rules that are there in our question paper. Please read them. Start each question on a new page. It is to your advantage. It is to your advantage. So you will be answering the three questions, 100 marks each, which will now take us to 300 marks. Then in the afternoon, you will be writing paper 2. Now paper 2, the first question is the multiple choice, map work. It will be the multiple choice. Then the next question will be the calculations. Then the 3rd question will be application of theory, application of your climate and weather, your fluvial processes and landforms, your settlement, your economic activities in South Africa, the application of those chapters. Then the last question, question 4 in paper 2, will be GIS. So the advice that I want to give you is, after writing your first paper from 9 to 12, have a break. Then after that break, come back and revise your calculations. Revise your calculations. That will help you to do well in your second paper. I wish you all the best. Let's go and do well in this forthcoming geography paper. We believe in you, and we know that you can make it. God be with you. Thank you very much.